So they have just given you that 1 centimeter long rod. Sorry, a 3 centimeter long rod. And a cross-sectional area, it's something like a cylindrical rod. Cross-sectional area is 1 centimeter square. So the volume will be 3 centimeter times 1 centimeter, 3 centimeter cube. Now, whenever they just give you these information, cross-sectional area and the height, better just roughly get an idea about the volume also. We're not dealing with the hydrostat questions. So they are saying that the density of the rod is same as that of the liquid. If you just read this question, the most important point is that the density of this liquid and the density of liquid will be the same. So density of both of them are the same. If it is rho, this is also known as rho. Okay. So now the thing is, this into this water. Sorry. They are just adding this rod. They are just adding this rod onto this liquid. So you should understand that what kind of change would be present. So you should understand what kind of a change will result here. So if I just look at a small example, I have a certain liquid filled to this level. And if I just drop a ball onto here, what would be the resulting change? If this plastic ball is going to float, if this was my initial level, the level of water at this point would rise up. So the water level at here and the water level at here will be different. In here, it has been risen to a certain height. Okay. So if I just recall you the Archimedes principle, what does it say actually? Anyone? What does the Archimedes principle says us? The thrust is equal to the weight. Exact, if you just look at the theory, the amount of weight, the weight of water displaced is equal to the weight of the object acting. So how are you going to find the weight? This will be the displaced volume. Displaced volume into density will get you the amount of water displaced. This is the displaced volume. I take it as V. Displaced volume into density of the liquid will get you the mass of the liquid. Mass of the liquid displaced. Okay. So just remember that point. And this will be equal to, as according to you said, by the Archimedes principle, this displaced mass will be equal to the mass of the object acting along here. This will be equal to the mass of the object. So V times of rho, if I just write it similar to this, volume times the density will get you the mass. So the volume of the object is, let's say V1, and the density of the object is rho1. The amount of water displaced will be V equal rho1 over rho times V1. I'll clear with this. I just want to say about the Archimedes principle because this is somewhat important. What does Archimedes principle says as is the amount of, so the weight of water displaced, weight of water, the weight of liquid displaced, okay? Let's take a general statement. The weight of liquid displaced is equal to the weight of object acting along here. So the weight of the object is mg. So just take it as simple m naught. And the weight of liquid displaced is the volume of liquid displaced along here, that is V, times the density of the liquid rho. Okay, times the density of the liquid rho. So as I said, by Archimedes principle, these two masses are the same. So I can equal these 2 points. V times of rho is equal to V1 rho 1. Just remember because they can somewhat modify this question. In here, they have said you the density of this rod, density of the liquid is the same. But there are cases you can get it's different, okay? So just remember this equation, how to obtain it. V times of rho is equal to V1 rho 1. So just keep this in mind. Now let's get into our point. We are given a rod P which has a cross-sectional area 1 centimeter square and the height of it is 3 centimeter. So the volume of this object is 3 centimeters cube. And what they're doing actually is they are just taking this rod and entering inside this U-tube. So you should get a basic idea that when you enter some object into a water level, the water level will rise up. Okay. So I'll clear with these basic ideas. Before we move to the simplification part, the same way you get this. Okay, fine. So yeah, that's the point. Now, since we are adding this object onto here, the water level along here will rise up and there will be a certain change taking place here. So let's draw a new diagram. This is my U-tube. And the liquid level has risen a certain amount. And of course, the water level. And let's take the common interface to be here. Now there will be different height. Capital HN. Let's say simple H. There will be capital H and simple H. Now I said your point that but there will be cases where the densities are different. Density of submerged object and density of liquid are different. But in here it is the same. So what can you say about the volumes? V rho is equal to V1 rho because the density of object and density of liquid are the same. So V rho is equal to V1 rho. Rho and rho cancel off. So now here you can see that V is equal to V1. So you can see on the way, now if you're doing for the first time, you might get this sort of equations. It's fine. So from that, I can just get a small short note for yourself. When the density of submerged object and the density of the liquid are equal, the volume of him is equal to the volume displaced by water. Or sorry, the volume displaced by the liquid. So you can just somewhat get a short idea because no matter whether it's a YouTube or whatever, in some other cases it will be helpful. Okay, so just get that short point. Yeah, that's it. So you should understand the volume of this rod P is 3 centimeter cube. When I enter this onto here, the volume displaced in the U-tip will also be 3 centimeter cube. Okay. The volume, okay, just write it there. Volume displaced in U-tube, that is also 3 centimeter cube. We get this conclusion from here, okay? So, what can you say about this additional height? If there's a volume displaced by 3 centimeter cube, how much height should the water level move up? Any ideas? Now we found that the volume of this object is the same as the volume displaced by here. So what height should be displaced in this point? Try to find it. Yeah, let's find it. They have just given you the cross-section area of the U-tube is 1 centimeter square. So if I just went to the equation, the volume displaced by the U-tube is 3 centimeter cube. So 3 centimeter cube is equal to 1 centimeter square times the height of this level. So it will be equal to again 3 centimeters. Sorry. I think I made a mistake. Just read the question again. They have given you that the cross-section area of the U-tube is 3 centimeters square. So be careful, okay? So the volume displaced is 3 centimeter cube. The cross-section area of the U-tube is 3 centimeters squared. So it is 3 centimeters squared times the height. Height which is displaced along here. Initially it was 10. Now it has displaced by some portion. Right? That's why I was saying it as simple h. So simple h is equal to 1 centimeter. So actually this U-tube is moving upward by 1 centimeter. Okay. So already initially it was at 10. Now the height will be 11. Okay. That's the only difference. Did you get that points? So if you are okay, I can just move to the next one. Fine. The basic idea which we obtain here, the height of this YouTube will be 1 centimeter. Sorry, the height of this level will be raised by 1 centimeter. So it will be having a structure like this. We have already done that. Initially, the height was 10. Up to here, it was 10. Now it has further rise by 1 centimeter. So overall height is 11 centimeters. Now we are supposed to find the height of this water level, right? I think you have to find the height of the water. Okay. So we have to find the height of the water level. Yeah, capital H is equal to 11 centimeter. Okay, I just erase that. Let's say it as capital, sorry, let's say it as 11. So I just erase only this section. So now we have to find this capital H. Let's say you are just trying for the first time. Sorry, let's take it as H naught, okay? So if I just write my equation, now just practice yourself to write it directly, because since it's an MCQ, no need to mention these atmospheric pressures. So if you just write directly 11 centimeter into density of this liquid, if I take it as rho, 11 centimeter into rho is equal to the height of this liquid H naught into rho W. Okay. Now, unfortunately, they haven't given you the liquid densities. Now, even you can say the water's density is 1000, but you don't know for him. So how can you proceed this part? Now, from this, I just obtained the equation 11 centimeter into rho is equal to H naught into rho W. Now, I should get some further information for this rho and rho W. So, from where I can obtain another expression? Any ideas? Using volume, yeah, you can do, right? If they have given you the weight, then it's a fine, okay? If they have given you the weight of him, then it is fine. Now, even don't take the density of him as 1000. I just want to find both of them's densities. From where I can just get a further information. Just think and see. You already have the solution to the board. And of course, if you just look at the paper, even you will be getting a solution. If we just had a normal YouTube question, I have just given you the height of him and him. How to find the relative density? Already I said the answer. Okay, sorry. The answer is actually you have to use from here because now see, I want to find rho and rho W, but I don't have further information. So if I just look at here, it is something like a basic ordinary YouTube question where they give you the height of the two liquid and they will be asking you to find the relative density, yeah, whatever the things. So mainly the relative density if it is water. So if you look at this information, the height of them are complete, unlike this. So I can just write an equation from here. Now try to write it directly, okay? Let's say this is from 2. From 1, I'm going to write an expression 10 centimeter into rho, 10 centimeter times rho is equal to 8 centimeter times rho W. 8. Now, another thing is, now if you're doing a structure or essay, you have to convert centimeters to meter. But since it is an MCQ, I'm not actually transforming them, okay? I'll say you the reason why. Because they are actually wanting you to find the height of this liquid level, which is in, if you look at the answers, that has been given in centimeters. So actually no need to convert them to meters, okay? Anyways, they will cancel off. So if you want to minimize time, just make sure that you're going to have it is in centimeters. So 10 centimeter times rho is equal to 8 centimeter times rho W. So I just obtain another expression from the first one. Okay. So these are my two expressions. Now I want to find this height h naught. So from here, I will equate, let's say rho over rho W. Rho over rho W is equal to 8 divided by 10. Rho divided by rho W is 8 divided by 10. And when I substitute onto here, 11 times rho over rho W is equal to h naught. Instead of rho over rho W, I will substitute this. So 11 into 8 over 10 is equal to h naught. So my h naught will be equal to 8.8 centimeters. Okay. Are you clear with this? If you had any confusion, just ask me, okay? That's not from Morto paper. It was from my provincial paper, okay? That's why I have just marked and those stuff. So just get the basic ideas. Now don't confuse yourself. I just had a rod here. Just think what will be the change. The actual change was there was a rise in water level. Okay, fine. Then I was just going around some equation to find them. Next time when you meet a question, just remember this expression. And moreover, if the densities are same, the volume displaced will be equal to the volume of the object you enter. And with the YouTube's cross-sectional areas, I found the height which is actually displaced. And from there I was moving, okay? So I hope you are clear with this. Now you can see that another one point. The height was 8 centimeter. It became 8.8 centimeters. Just because this was increasing, this doesn't decrease. This is also going to increase. There's a method to find that as well. Do you know that method? Do you know that method actually? Or else I can just teach you that. Without writing this equation, there's a method 2 as well. I'll just get you an idea with that. So the next time, if they just change the density even, you can use this equation. And most often they'll be giving for a lower density one. If the density of this guy is lower than him, this rod is gonna float in this liquid. Okay. So any doubts in here? Okay, so the method 2 is, shall I erase them? Okay, so let me just erase them. Now the method 2 you can try is, just get that point. Even you can get a question with that. Another one is, you can also get a question like this. They might say you, uh, the same liquid was poured for a volume of 3 centimeter cube. That is also same idea, okay? So the thing is, you should understand there's a small concept in YouTube that is whatever volume displaced by here is covered by him. Okay, you can just use that idea as well. So let's say, I don't think it will work. Let's just try it, okay? What will actually happen is, if I had a certain liquid from my common interface, if I start pouring liquid onto here, there's actually an additional volume. That additional volume is covered from this section. That means this will also increase. Slightly, this will also increase. So let's say, by adding this liquid, this common interface went down by a distance x. So what will actually happen is, from here, the common interface will rise also by distance x. And only if the cross-sectional area of the U-tubes are the same, okay? Whatever volume subjected here, what will happen is this common interface will move down, causing this common interface to move up. Okay, from here this will rise up. Only if the cross-sectional areas are the same height will be displaced. Or else what you have to do is, now if it was A1, A2, you have to use A1, X1 equal to A2, X2. Using this, you have to find the height of the other one. Okay. So now what will be your new diagram is, this will be my U-tube. And from my common interface, now my common interface is here. So it is here. This has went down. So this is here. So you must be careful with that. Just a minute. This common interface will move down by distance x. Here it will be rising out by distance capital X. And, so this will be at a height, I think. Yeah. So this is x1. This part is x2. So the height of the liquid level will be x1 plus x2. It will be x1 plus x2. I think it's not. Okay. Here it went down by x1. This was my initial common interface level. From here it went down by distance x1. From here it went up by distance x2. So the height of the water level from the common interface will be x1 plus x2. Will x1 plus x2. So inshallah, I'll just get you a better question for that. For now, just get that idea, okay? Whatever volume created here is displaced. So the volume displaced here is equal to the volume covered from him. So A1 x1 is equal to A2 x2. So only if the cross-section areas are the same height will be displaced. So using this, just try that, okay? Let's see whether you're going to get the answer. So I will be up to here. Then. So I will be up to here. Fine. So let's wind up to here. Inshallah, from the next week, let's make it a bit long. And yeah, if you have any time issue, just say me, okay? Because I think from today my exams are over, so you can shift it anytime. And most important, try the question number 2 again, okay? You will forget that in while. It will be really, really important. Yeah, this is also somewhat a good question. And of course, this tute consists of so many questions in this pattern. You have to think somewhat, and there will be some tricks to deal this question. Okay. Yeah, fine. If everyone is okay with that time, yeah, just, and yeah.